Hi and welcome to my maths class. Today we are doing a revision on grade 11 trigonometry, general solution. Now from your previous grade, you know that you have to get your ratio alone. Number 2, when you use your calculator, don't put in a sign. Number 3, you're going to do the t. But your t is based on your sign and your restriction. So we're going to still use our basic Cartesian plane where we have all students take coffee, and we're going to look at that restriction. But the sums for general solution are not always that easy. Okay, let us do a few examples. Now the general one that you would have done would be from grade 10, where we'd have like tan theta is equal to minus root of 3. You'd press shift tan root of 3. Remember, don't put the sign in your calculator. So we have theta is equal to 60 degrees. Now we have a sign limit. If they don't give us a restriction, we accept it as 0 to 360. Now tan is negative in the second and in the fourth quadrant. Because I don't have a restriction, I'm going to accept it from 0 to 360. So we know that we are using the second and the fourth quadrant. Now when we are using the second and fourth quadrant, we are still using the same information from our Cartesian plane. In the first quadrant, the standard value, second quadrant 180 minus theta, third quadrant 180 plus theta, fourth quadrant 360 minus theta. So this Cartesian plane and the information on it, we continuously use it. Now let's go to our solution. We know we are working in the second and the fourth quadrant. So we have our second and we have our fourth. In the second quadrant, we have theta is equal to 180 minus, what was our answer? 60 plus k 180. Now why am I saying k 180? Because 180 is the standard period for a tan graph. 360 is the standard period for a cos or a sin graph. When we're using general solution, we're using their standard periods in the equation. For the fourth quadrant, we have theta is equal to 360 minus 60 plus k 180. Simplifying it, we have theta is equal to 120 degrees plus k 180, and we have theta is equal to 300 degrees plus k 180. Right, let us do more challenging examples. When we are doing general solution, you must remember that the part that is immediately next to the ratio does not move. Right, number 1, we're going to get our ratio alone. So I have cos 2a is equal to minus root of 3 over 2. Now we're not going to get rid of that 2a because it's immediately next to our ratio. So we press shift cos root of 3 over 2. Remember, we're not putting the negative sign in our calculator. So what do we have? We have that 2a is equal to 30 degrees. How do we decide which quadrants we're working in? Look at the restriction. We have a negative, so cos is negative in the second and the third quadrant. Look at the second restriction we have. Tan 2a is less than 0. What are they saying? Tan is negative. Where is tan negative? Tan is negative in the second and the fourth quadrant, which means that in this solution, we are only working in one specific quadrant, which is the second quadrant. So my t is only going to have one part to it, which is the second quadrant. The second quadrant says that 2a will equal to 180 minus 30 plus k, because I'm working with the cos, it will be cos 360. Now we have to get a alone. So I have 2a is equal to 150 plus k 360 divided by 2, and once you divide by 2 you have to divide every term by 2. So I have a is equal to 75 plus k 180, giving us the general solution. Usually when they give us a general solution, they would give us a continuation of the question where they put in something to this effect. Right, determine all the values of a if a basically lies between 0 and 360 degrees, which means now they want you to limit this answer to the values that lie between 0 and 360. What you do in that case is we start substituting in the values of k. So we can, the standard substitution is 0, 1, 2, minus 1, minus 2. We get the answers of a. As long as they lie between 0 and 360, they are accepted. Once they exceed that, we don't count it. So let's try the first one. A is equal to 75 degrees plus, in place of k, I'm making it 0 times 180, which gives me an answer of 75 degrees. Then a is equal to 75 plus, let's try 1, which gives me an answer of, right, if I try minus 1, that will give me an answer of minus 105. Can you see this would not be accepted because our limit is between 0 and 360. So once you know minus 1 is not going to work, you don't continue at minus 2, minus 3, they stop. But let's try 2. A is equal to 435, but that is not within the restriction. So what are our answers? Our answers are where k is equal to 0, a is equal to 75, and where k is equal to 1, a is equal to 255. And those are your final answers if they say determine the values of a. If you look at the following general solutions, you will notice in the first question, the angles are the same. Whereas in the second question, the angles are not the same. When the angles are the same, what we do is we use the tan function. So we divide by cos on the one side and we divide by cos on the other side. Sin theta divided by cos theta, which gives me tan theta is equal to 3. Now we have a standard general solution. Shift tan 3 and I'll have theta is equal to 71,6 degrees. We know that tan is positive. So if tan is positive, it's positive in the first and in the third quadrant. So for the first quadrant, we have theta is equal to 71,6 degrees plus k 180, and for the third quadrant we have theta is equal to 180 plus 71,6 degrees plus k 180. Theta is equal to 251,6 degrees plus k 180. Now let's look at the following sum. If we have cos x plus 10 is equal to sin 2x. We can't use the tan because the angles are not the same. So what we do is we use reduction. Sin is the same as saying cos 90 minus 2x. From our reduction, we know if I say cos 90 minus 2x, when I reduce it, it will become sin 2x. Once we have the same ratios, we cancel it out. But as soon as you cancel it, you have to go to your t. Now, because they are both unknowns, it is accepted that it is a positive version. And since we cancelled out cos, we are working with the cos reduction. So we have cos positive in the first quadrant and the fourth quadrant. Let's do the first quadrant first. We have x plus 10 is equal to 90 minus 2x plus k 360. Now we're going to solve for x. When I take the 2x over, I'm going to end up with 3x is equal to 90 minus 10 plus k 360. So we have 3x is equal to 80 plus k 360 divided by 3. We have x is equal to 26,7 degrees plus k 120. Now let's do the fourth quadrant. Why am I choosing the fourth quadrant? Because I'm specifically working with cos. And since they are unknowns, we accept it as positive. So for the fourth quadrant, we have 360 minus, open brackets, 90 minus 2x plus k 360. So it's x plus 10 is equal to 360 minus 90 plus 2x plus k 360. If we take our 2x over, I will have minus x is equal to 360 minus 90 is 270 minus 10, which will give us 260 plus k 360 divide by negative. So I have x is equal to negative 260 minus k 360. Thank you for watching.